What will the future look like? How will you live? What will you do? Will you change the world? Transform a small beginning into a great adventure. Imagine, create, shape, become involved. Learn to define your future. Be a part of defining the world's future.
Okay, so I see it. So what are we seeing?
So this is a scaffold, and basically, again, it's like Jell-O or a soft contact lens, and what we're doing is we're making these types of devices that are amenable to being implanted into the body and that have very specific chemical configurations that they can actually guide the regenerating axons within these types of materials. So what is special about these gels compared to, for example, Jell-O or a contact lens is that it's a sugar molecule that plays a natural role in wound healing. And so it biologically encourages the body to regenerate. So inherently the scaffold itself has some wound healing properties. So that's what we're trying to avoid, is the need for having to remove nerve tissue that's healthy from one part of your body and having to implant that. Can we design something like this? One of these types of scaffolds that could do that without having to remove that healthy nerve tissue from the body. And then ultimately, again, for spinal cord injury where there are no current therapies available at this time.
We have a saying, what starts here changes the world. Begin your adventure with the University of Texas at Austin.
This UAV here is not a first-generation aircraft.
Right.
Tell me a little more about that.
So the first generation aircraft that the students designed was designed to carry a video camera and designed to be operated by a pilot. So it was not an autonomous vehicle. And that vehicle was our learning vehicle. This is the first vehicle, however, that's designed to be an autonomous vehicle.
Well, this is the ASDL lab, this is the Air Systems Design Lab. It was funded by Lockheed Martin. Starting from last year, we started building this lab. It's not completed, but it's getting very close to it. In this lab, what we work on are different UAVs. This right here is technically it's our second generation UAV. It's called Murcielago. This is a very sophisticated airplane. We use this as our autonomous platform. Basically, this airplane here will one day be able to fly by itself.
Yeah, so basically what we're trying to do with the third generation is design a plane that can carry a sensor that we would use to measure the distance between the aircraft and the ground. And we can do these measurements very accurately to such an extent that we can start to look at problems, for example, of ground subsidence. What happens in a city as water is removed from underground? What happens as the whole ground starts to sink down? And so we would like to know about that. It has all kinds of implications. For example, what if the area in a coastal region was subsiding? Well, then eventually you could imagine there being flooding problems or problems that might be magnified during tropical storms or hurricanes because the ground is now lower. So one of the applications of the UAV is to be able to do those mappings, repeatedly, to do them inexpensively, and that then provides information to researchers and to government officials to look at what might be happening with the ground.
Be a part of the Longhorn tradition. Embark on an exciting experience of opportunity and possibility. Here is where you start. Here you can change the world.
Ports represent some of the most important pieces of our economic infrastructure. Yet, a lot of these ports have a high seismic risk, not only because of where they're located, such as shown here, LA, Long Beach, Oakland, and Seattle, but because of how they were constructed, with poor soils that are potentially liquefiable. Now, one of the best examples for how earthquakes might influence a port is the port of Kobe, which was shaken during the 1995 Kobe earthquake. And because of the damage that was sustained, the port of Kobe went from being the 6th largest port in the world to today being the 35th largest port in the world. It simply never recovered from the damage that was sustained. Economically, we've seen in the U.S. that closing a port for one day can cost over $1 billion to the local economy. Well, this is one of our large-scale mobile shakers that have been funded through the NSF Network for Earthquake Engineering Simulation, otherwise known as NEES. And this shaker you're looking at here is affectionately known as Liquidator. What you have here is our large-scale base plate. So this base plate comes down and rests on the ground and can apply tens of thousands of pounds of force. And then the base plate can vibrate either vertically or horizontally to create various types of vibrations and stress waves that propagate through the soil. One soil improvement technique we're looking at is prefabricated vertical drains. And we're looking at it in the field with the field shakers, but we're also looking at it in scaled models that we are testing on a geotechnical centrifuge. And in the geotechnical centrifuge, we can test side by side liquefiable soil deposits that are treated and untreated, shake them and see how their responses are different. We've had some discussion with port operators, and they're very interested in these soil improvement techniques because they know that they have a large seismic risk.
These engineers represent just a fraction of the significant contributions made by faculty and alumni at the University of Texas at Austin. What is your dream? What will you do?
Design and research prosthetics to help kids who can't do sports because of certain injuries and things like that. My goal is to work in rockets and satellites at NASA.
I wanted to design aircraft, and that's been my passion for a long, long time.
A problem solver is the role I'd like to achieve.
Just get us on the way to developing some sort of a cure for cancer. That's really what interests me.
What starts here? Your immersion at a first-rate university, your personal growth and development, your successes and accomplishments. We welcome you to the University of Texas at Austin.